All right, so in the second video, we're going to start up our section 2 notes actually. So the objectives for this section are to perform these ideal stoichiometric calculations. So the type of calculation I did in the last video is a stoichiometric calculation. It's a weird word, but this does say ideal. You see this ideal label in front of it because we're assuming that nothing is limiting. So obviously when you have reactants, you can have limiting reactants, and we'll talk about that in section 3. But right now we're assuming that we have exactly how much of A we need to react with an exact amount of B to make an exact amount of C, which doesn't really work in the real world. Sometimes you run out of one of those reactants and you can't make as much of the product as you might think you will. So we'll talk about that later, but these are technically ideal stoichiometric calculations right now. So again, I really just need to start going through examples with you guys, and you need to be able to pay attention and follow along and understand these things. It's not that difficult when it's all said and done. You just need to learn what it is that you're trying to do every time. So this first example here, hydrogen peroxide decomposes to form water and oxygen gas. We talked about a lot of things in the past, and you have to be able to put it all together to make something that functions here. So the first thing I'm actually going to need is an equation. And I didn't tell you that one from the get-go here. You're supposed to be able to figure it out for yourself. Now, it says that this hydrogen peroxide is decomposing to make water and oxygen. Hopefully, after last chapter, we can write an equation for that pretty easily. And we can balance it appropriately. Since I see there are 3 oxygens on the right and only 1 on the left, that might be an issue, right? So, well, excuse me, I wrote that wrong anyway. There's 3 oxygens on the right and there's only 2 oxygens on the left. Don't do what I did and screw up your equation from the get-go. But in order to balance this, I need 2 waters actually, and that means I'm going to have 2 of these hydrogen peroxides. That gives me 4 hydrogens on both sides and 4 oxygens on both sides. So I need to be able to balance an equation. I need to be able to write an equation from scratch if necessary. Because again, you have all this prerequisite knowledge. You've been learning all this stuff for a reason, so you can actually use it. But then the next step is to understand what was given to you in the problem and what you want, right? So I was given essentially 5 moles of hydrogen peroxide. And I want to know how many moles of oxygen will be produced if I had 5 moles of hydrogen peroxide that react. So I'm relating these 2 things, hydrogen peroxide and oxygen, and it's just a mole relationship here, right? I'm starting with moles of A, right? And I want moles of B. So this is actually the simplest kind of problem we can have. This is the problem that you've already done multiple times, right? Again, I always write out what I want to do because it helps me organize my work. If I want to change moles of A into moles of B, I'm going to have to divide by moles of A here. I'm going to need a ratio of A and B, which is pretty easy because A happens to be hydrogen peroxide, and B is the oxygen over here, and there's a 2-to-1 ratio because I already balanced that equation. So again, I'm just going to start with what was given, 5 moles of hydrogen peroxide, and I'm going to convert into moles of oxygen. So again, it was 1 mole of oxygen in the equation. There was a 1 in front here, even if I didn't write it. And 1 mole of oxygen is produced for every 2 moles of hydrogen peroxide that react. That cancels my label. That helps me get an answer of 2.5 moles of oxygen. Again, I have to pay attention though, because it did say 5 moles to begin with, and 5 only has 1 sig fig, so I'm going to round this. If I was going to write this answer on a test, I need to make sure I round it appropriately. My final answer would be 3 moles of oxygen because that has 1 sig fig. Usually I'd give you more sig figs than that, but in this case it is what it is. But again, I used a mole ratio, and that's all I had to do in this case because I wanted moles and was given moles. So in that first video for this chapter that I did a much longer problem that had multiple steps. Understand, I'm not always going to do that whole string. Sometimes I'm only going to do parts of it. And in this case, I only need to use a mole ratio to get my answer. And I know that because it was moles over moles. That's a ratio, right? So we get to another kind of example. Again, just going to do a lot of examples and hopefully you can figure things out as we go. At this time, I was nice enough to give you the equation because there's no way you knew what sodium azide was. It's apparently that NaN3 compound below. But sodium azide is activated in an airbag, and nitrogen gas and sodium are produced according to the following equation. Notice that sodium azide is a solid, and so is the sodium, but that nitrogen is a gas, which is kind of important because you wanted your airbag to be full of air, some kind of gas, so you would hit it instead of your windshield. So kind of an important reaction. Hopefully you never have to use an airbag in a vehicle, but that's how it works, apparently. So I need to balance this equation. I need to convert some things and just start with what you know. I got to balance this thing. I got a 2 over here and a 3 over here. So it makes sense to me to just go 3 and 2 to start. That way there are 6 nitrogens on both sides. But then I need 2 sodiums on both sides. So I got a balanced equation. And I have a question down here that gave me moles and is asking for a mass, right? Now, again, we do this over and over again, and I want you to get better and better at understanding what you're supposed to be doing. But essentially, I'm giving you moles of A, and I'm asking you for grams of B, right? But if you look at our original string way back here, I can't change moles of A directly into grams of B. I have to change moles of A into moles of B first. So again, moles of A needs to be changed into moles of B. Then I can change moles of B into grams, of B into a mass of B. I'm trying to figure out what my work should look like. So I know since there's moles of A here, I should put moles of A there. Moles of B here, I should put moles of B here. And you should recognize from before, like I said, this is a mole ratio. So I'm going to use my balanced equation for that. This is a molar mass, which in this case, I'm going to use the periodic table because B is a real thing. B is nitrogen that I'm trying to come up with, right? The sodium azide essentially is A in this case. Nitrogen is B. So I need a mass, a molar mass for nitrogen. So I need to know what 1 mole of nitrogen weighs. And on my periodic table, nitrogen is 14.01, but notice that nitrogen is diatomic here, so I have to double that number. 1 mole of nitrogen is 28.02 grams. The mass of 1 mole of nitrogen gas is 28.02 grams. So I'm going to use a mole ratio and molar mass, but I'm just going to start with what was given, 0.500 moles of that sodium azide. Again, I'm starting with A. I'm doing it in a molar ratio, and it says B over A, right? I need to put nitrogen over sodium azide. So I'm going to, again, use my equation here. I'm going to put 3 moles of nitrogen over 2 moles of sodium azide because that's how it balanced. That covers my mole ratio. Then I need to do a molar mass, which happens to be this amount because I looked it up already on the periodic table. So again, put the grams on top, 28.02 grams per mole. So 28.02 grams. Should put nitrogen labels on both of these things. Again, I can write a 1 or I cannot write a 1. It doesn't actually matter because I'm not going to multiply or divide by 1s because that doesn't change anything. But now if I do multiply and divide, if I take my 0.5 times 3 times 28.02 and then divide that answer by 2, I'm going to get an answer on my calculator of 21.015, right? And my label is going to be grams of nitrogen, but also I have to take care of sig figs, remember. This 0.500 that I was given to begin with has 3 sig figs, so I need to round this to 3 sig figs. So I'll do that real quick. 21.0 grams of nitrogen. That's going to be my answer for this. Again, not actually all that complicated, or excuse me, not actually all that difficult, but it is kind of complicated. It is hard to set up these problems and come up with answers every time. It can be difficult to do that. So we'll do, actually I'm going to break it up here. Let's go ahead and stop the video and